Yaskawa.
Welcome to Yaskawa America's e-learning module, R1000 Features and Benefits. Hi, I'm Stephen Peterson, and I'm one of the product training engineers here at Yaskawa America. In this e-learning module, we'll be discussing features for the R1000 Power Regenerative Unit. To understand what the R1000 is and when it is practical to use, let's start with a brief lesson on regenerative energy, commonly called REGEN for short. Regenerative energy is defined as the electrical energy created as a result of a motor shaft turning faster than the drive's output frequency. This is because an overhauled motor acts as a generator. Think of it this way: when a motor turns, it consumes energy, but when it is turned by something else, it generates energy. For example, conveyors, or applications with high inertial loads, when we slow this down or we stop that load, it regenerates energy. Even variable torque loads, such as fans or pumps, can have external forces turning the motor, resulting in regenerative energy. Now you may be thinking, hey, my application generates energy? Great, so what happens to that energy? Where does it go? To answer that question, let's look at one more application example and discuss how regenerative energy can be a double-edged sword. Pretend we have a downhill conveyor with the drive running the motor on that conveyor. In this application, there is a lot of regenerative energy due to gravity on the product. The drive will command the motor to run at a certain speed and direction. This is the speed reference. Because of the weight of the product on the conveyor and the force of gravity, the conveyor will naturally want to accelerate downhill without the need for the drive to perform any work. When the conveyor starts to run faster, due to gravity and the load, the motor must hold the load back to maintain the commanded speed reference. This is called holdback torque. During this time, the motor is being overhauled and is in constant regen. The regenerative energy is applied back to the drive, and this can cause issues. Let's see what can happen. While in regen, the energy goes back into the drive and charges up the DC bus capacitors. The rectification circuit on the input of the drive is a one-way street, so the DC bus voltage as it rises has nowhere else to go. The DC bus capacitors can only store so much voltage. If that voltage level keeps creeping up and rising, an overvoltage fault will occur. To prevent the drive from tripping out like this, we must integrate some sort of external hardware to properly handle that regenerative energy. Before reviewing the available options for controlling regenerative energy, it is important to understand the term duty cycle. Duty cycle is expressed as a percentage. So when we are talking about regen, this percentage reflects how much time out of one cycle an application is in regen. Knowing this, our example with the downhill conveyor may have 100% regen if the conveyor is fully loaded. This is considered continuous regen. The less time an application is in regen, the lower the duty cycle. This is key information to know when you are matching a regenerative option to a given application. If an application is braking for 10 seconds out of a 100-second cycle, we divide that braking time with the cycle time to calculate the duty cycle percentage. One thing to note is that Yaskawa often lists ED instead of duty cycle when it comes to ratings of regenerative components. ED simply stands for Einschaltdauer, which is actually German for duty cycle. Here's a quick quiz to test your knowledge. An application is in a regenerative state for 1 minute and a motoring state for 3 minutes. Calculate the duty cycle. You should find that the answer is going to be 25%. So we got this by figuring out what the whole cycle was, so 4 minutes total. We were in regenerative state for one of those minutes, so 1 over 4 is 25%. So what are the available hardware solutions commonly used to handle regenerative energy? Most commonly, when dealing with low amounts of regen, dynamic braking is used. Dynamic braking will consist of a dynamic braking transistor, also referred to as a chopper, and a dynamic braking resistor. When regenerative energy is present, the transistor closes, allowing the energy to bleed off onto the resistor. This method is primarily chosen due to the relatively low cost and simplicity in wiring and installation. However, with dynamic braking, there are no energy savings. All of the energy dumped onto the resistor is simply burned off and wasted as heat. Additionally, when an application calls for a higher duty cycle due to increased regen, the size of the braking transistor and resistor will get larger and could multiply. Braking modules are run in parallel. This results in a larger footprint and more wiring. Dynamic braking is most commonly used on applications requiring a duty cycle of 10% or less, but it is not limited to that number. On applications with higher regenerative energy present, an active front end, or AFE, can be integrated. An AFE connects to the drive's DC bus and into the three-phase power utility. Regenerative energy is directed into the AFE, which is wired in series to the drive. The regen converter then takes this energy and pushes it back onto the utility line. An AFE will provide energy savings since we are putting the energy back onto the line. This is a benefit over dynamic braking, where the energy is simply wasted as heat. This converter has a high regen capacity and will mitigate harmonics. An AFE has a large upfront cost and should only be selected for applications with continuous regen where harmonics need to be addressed. It can be sized to handle up to 100% continuous energy dissipation. After looking at the various techniques available for handling regenerative energy, let's now look at Yaskawa's R1000 regen unit, which offers huge benefits on many different levels. The R1000 will eliminate overvoltage trips that were caused by regenerative energy. This is due to the unit's ability to continuously convert 80% regenerative torque and apply it back to the supply source. When an application's regen can be put back onto the line, a significant energy savings will be benefited from, and a large cost savings will result. This will reduce that monthly electric bill. This is all possible due to the R1000's unique design specifically developed to recycle an application's wasted energy. Regenerative energy is typically cast under a negative light since it can cause faults and also downtime, which can be costly. Oftentimes it is addressed with a series of resistors. As we know, this is dynamic braking, and these resistors will simply burn off that regen as heat, which is wasteful. This is pretty much the equivalent of burning your money. The R1000 captures this energy and applies it back onto the line. The R1000 makes regenerative energy green energy. Now let's look at how it accomplishes this. The R1000 is wired in parallel to an AC drive via the DC bus. Regenerative energy will flow into the R1000 unit. The R1000 takes this regenerative energy and converts it from DC to AC and applies it back onto the utility. The R1000 is internally configured so that current is going to flow unidirectionally, so it will only flow back onto the utility. These reactors and fuses are necessary for proper operation and protection of the R1000. The good thing is that these components have already been spec'd for each capacity R1000 by Yaskawa. They are available to purchase through your local distributor or sales channel, and of course along with the R1000 itself. The R1000 will be released for both 200 volt and 400 volt supplies. The 200 volt class is rated for 200 to 240 volts AC. The ranges vary from 3.5 kilowatts up to 105 kilowatts. A maximum voltage deviance of minus 15% to plus 10% is allowed. For the 400 volt class, this allows for a 380 volt input all the way up to 480 volts max. This class features a broad spectrum in capacities varying from 3.5 kilowatts to 300 kilowatts. The same minus 15% to plus 10% voltage tolerance exists. Yaskawa has always tried to keep consistency at the forefront. whether it be consistency in quality, product lineups, or even something as simple as the model number. For those of you familiar with Yaskawa's 1000 series lineup, this model number breakdown should be nothing new. The R will naturally designate the unit as an R1000. Following that, there will be a region code, a voltage class, and also a spec. In addition to the voltage class, one of the most important designators is the rated capacity. This value is in kilowatts and designates how much regenerative power that specific R1000 is rated for. This differs from our drives, which are rated for an output current. The last three designators will determine the chassis type, any add-in environmental specs, and the revision of the unit. Selecting the proper R1000 for your application is dependent on the voltage class and also the amount of regenerative energy present. Depending on the amount of regen present, you may be able to select an R1000 with a smaller capacity than the drive that's being applied. For example, if you have a 480 volt 22 kilowatt drive on an application, if this application has low regen, you may be able to use a smaller 14 kilowatt R1000. There is also an easy selection table available for use in the product catalog. This table will size the R1000 based on the drive motor capacity. Knowing the kilowatt rating and utilizing this table will yield an R1000 size for 80% continuous duty. It is important to understand that sizing should be done as one R1000 to one drive. Never size or wire up one R1000 to multiple drives. Here's a quick question. What is the recommended R1000 to use with a 230 volt, 45 kilowatt drive motor combo, assuming 80% continuous duty? Using the easy selection table, you should have found that the CIMR-RU2A0053 FAA is the right unit. While we are on the topic of duty ratings, here's some performance ratings for the R1000. The R1000 can handle up to 150% regenerative torque for 30 seconds. 100% for 60 seconds, and 80% regenerative torque continuously. Notice how at 100% regenerative torque, the duty cycle must be 25% or less. To simplify what that means, we can think of an application that regens 25% of the time. For example, 1 minute on and 3 minutes off. During that 1 minute, the R1000 can handle 100% regenerative torque. The R1000 is a very versatile unit as it can be paired with any of Yaskawa's industrial drives. This includes the A1000, V1000, J1000, L1000, and also the G7. The main circuit connections are relatively simple and straightforward. Remember, the R1000 is wired in parallel to the VFD. Knowing this, the DC bus from the drive is wired to the DC voltage input of the R1000. For the AC side, notice that there are two sets of 3 input terminals, whereas with a standard drive, commonly you only see one set. The capital RST terminals are the power supply inputs. These terminals power the R1000. Now, despite them being called inputs, they are also outputs. This is because this is where the regenerative power goes back onto the line. To clean up the regenerative power, in line with that is a current suppression reactor and also some fuses for protection. The power coordinating reactor is wired before the fuses. The second set of the input terminals, lowercase r1, lowercase s1, and lowercase t1, are used for detecting phase order. Notice how these wires are landed before all of the reactors. These wires are necessary so that the R1000 can properly apply the regenerative energy back to the utility with the correct phasing. The R1000 sequencing can be integrated into any new or existing application. A systems integrator can opt to wire a forced or an automatic operation command. A forced command will manually start the region's unit operation. The automatic command can be considered a little bit more intelligent, as it will activate and deactivate the R1000 as the DC bus voltage increases or decreases. So it will only be operating when the application is in a regenerative state. The R1000 has plenty of I/O to go around. Standard on all R1000s are 8 programmable, optically isolated digital inputs. There's also 1 designated fault contact, which operates on a Form C relay, and 3 additional programmable contacts, which are Form A relays. Lastly, there are 2 programmable analog output monitors, which can source 0 to 10 volts or 4 to 20 milliamps. All of this robustness that is the R1000's I/O is located on the removable terminal card. The removable terminal card is beneficial as it automatically backs up any programming changes to the unit. In addition to all the programming being backed up, your wiring is also stored on here. So unit replacement will fly by in no time, minimizing application downtime since all the wiring does not need to be relanded and the parameters are already backed up. For example, if an R1000 unit must be replaced, simply remove the terminal card, dismount the old R1000, and mount the new R1000. All of the application's wiring and programming are on the original terminal card. Simply plug in the terminal card into the unit, load the backup, and you're on your way. The R1000 comes in both open chassis and NEMA Type 1 enclosures. The IP00 or open chassis type units can operate in an ambient temperature of -10 degrees to 50 degrees Celsius. The IP20, also known as NEMA Type 1 chassis units, have an ambient temperature range of -10 degrees to 40 degrees Celsius. Additional environmental specs can be found in the R1000 technical manual. Is a NEMA 1 type enclosure a necessity? Well, don't worry, because NEMA 1 kits are available for all open chassis units. Here at Yaskawa, we understand how important and costly space is. The R1000 design features various size and installation reductions, resulting in less space needed and a quicker installation time. To sweeten the deal further, the R1000 can be mounted as close as 2 millimeters, side by side, next to the drives it's connected to. This is virtually touching, and will maximize the limited space you may have. Be sure to reference to the technical manual for further information about a side-by-side mounting setup. Just like a drive, the R1000 needs to be mounted upright for proper airflow. In most instances, the R1000 will be mounted as close to the drive as it is paired up to as possible. This minimizes the length of wiring needed between the 2 units. You may find it optimal to put your drive, R1000, and additional components such as fusing and the reactors all in one enclosure. A nice benefit of the R1000 is that the keypad can be mounted remotely since it is removable and can run off a standard straight-through Ethernet cable. Additionally, complete remote mounting kits are available through Yaskawa, making it easy to integrate the R1000 into an existing or new enclosure. Alright, time for a quick quiz. How close can multiple R1000s or Yaskawa AC drives be mounted in a side-by-side arrangement? The answer is 2 millimeters. The ease of programming is a critical benefit on all Yaskawa products. The R1000, of course, is no exception. Stress-free programming is provided since all parameters are organized into groups, making finding what you need simple and efficient. The R1000 features a full-text keypad. The standard display is an illuminated LCD type, making it easy to read and interpret. The keypad offers parameter backup capability with memory built right into the keypad. Navigation is also intuitive and works the same way as Yaskawa's other 1000 series keypads. Additionally, there are multiple available languages that the keypad can display. To accelerate setup and programming further, Yaskawa's PC tool, Drivewizard Industrial, can connect to the R1000 with a standard type A to B USB cable. This software is free. The software features the ability to create and save parameter files without the need of being physically connected to the unit itself. Programming from the R1000 can be backed up for storage as a number of different file types for personal reference or for sharing and sending to others. Live parameter editing can be performed, as well as graphic trending for up to 6 monitors at a time. The R1000 features a monitor menu. This menu contains a wealth of monitors to make operation and troubleshooting easy. There are a number of basic operation status monitors, which include input and output terminal status. Since the R1000 is a regenerative unit, there are many critical monitors for power supply voltage, current, and frequency levels. Also, DC bus voltage feedback can be monitored. Additionally, there are a number of special monitors that are available based on the main reason why the R1000 was developed, and that reason is energy savings. For example, you can monitor the total amount of regenerated power. The R1000 also features the ability to program your current power unit price right into the parameters. By doing this, you can then take advantage of additional monitors that calculate the money spent to consume electrical power, and also the money saved based on the regenerative power created. If a fault were to ever occur on the R1000, we've got you covered. The unit can be set up to automatically restart on a fault if desired. There are also a number of faults ingrained into the R1000's programming to protect the unit and your application. To name a few, there is a power supply overvoltage and also undervoltage detection, overcurrent protection, overload, input phase loss, and also phase order detection. There are also 2 monitor groups solely dedicated to helping the operator troubleshoot any fault. The U2 monitor group will list what occurred at the most recent fault. Think of it kind of like a snapshot that was taken during a fault to list all of the monitors you will need to make an analysis of what exactly happened. Secondly, the U3 group is your fault history group. This will list up to 10 of the most recent faults. This is great for tracking previous faults and also checking for patterns. The R1000's internal components are tied to yet another set of monitors, the U4 Performance Life monitors. These display what percentage of the estimated life of each component has been used. Once a certain level is reached, the keypad will give you a friendly reminder that preventative maintenance is recommended for the aging component. Quick quiz time. Which monitor group is like a snapshot of the most recent fault? The answer is the U2 fault trace group. The fault trace group can be described as a picture or a snapshot that was taken when the unit faults out. This snapshot stores key operation monitors so that the unit's troubleshooting can be done more efficiently. Yaskawa, reliability, and quality go together hand in hand. The R1000's components, such as the fans, capacitors, and relays, are rated for a 10-year lifespan. The R1000 also struts an industry-leading 28 years mean time between failure. Meeting the correct standard is a necessity for panel builders and equipment users. The R1000 is UL recognized for both Canada and the US, and carries the CSA mark. The R1000 will also be appropriate for use throughout Europe since it meets CE requirements. The R1000 also uses all RoHS-compliant materials. The R1000 features many options as far as network communication protocols. These options will enable the R1000 to connect and interface to an industrial network for control and/or monitoring. The available options are DeviceNet, Profibus, Ethernet IP, Profinet, Modbus TCP/IP, and the unit's native protocol, Modbus RTU, which does not require an option card. The R1000, as mentioned, is able to adapt to a large list of different applications. The R1000 can also be customized to your application, since Yaskawa offers a deep list of optional add-ons for the R1000. The R1000 has 3 serial ports, rated at 1 megabit per second on the control board for the connection of option boards. With 3 option board ports available, many combinations of installed option boards are possible. An analog output option adds 2 additional analog signals to the R1000 for use with metering or monitoring operation. An available digital output card provides 8 additional digital outputs for monitoring the statuses. The 24-volt control power unit option provides board-level component voltages for the R1000 when provided with 24 volts from an external customer-supplied source. It is used to maintain both drive control power and also network communications. The Y stick is Yaskawa's USB copy unit. This device can be used as a USB pass-through for connecting the drive to the PC through the DriveWizard software, or it can be used to read and copy the R1000's parameter set. To recap, many applications can benefit from utilizing the R1000 Power Regenerative Unit. Using the R1000 allows you to eliminate wasteful dynamic braking packages. Instead of burning off the energy as heat, the R1000 returns the energy back to the line, recycling it. This will save you money and also reduce your carbon footprint. The R1000 can be applied to many different applications on conveyance equipment. This includes conveyors, elevators and escalators, storage units, and also transportation. Additionally, there are a number of manufacturing applications that apply. Textile, presses, centrifuges and decanters, mixers, winders and rewinders, web applications, machine tool, and many more. Well, we've come to the end of this training program, but it is definitely not the end of our commitment to make Yaskawa drive and motion products the best in the industry. To us, quality means doing everything to make our customers, partners, and employees' experience a great one. We commit to that. We make it happen. We can, because to us, it's personal.